we can show the sampling error, which is actually uncertainty in the orientation of regression line that you make for the sample comparing to the true orientation of the regression line that you make for population in a slightly different way. So we have also a data set with two variables, x and y, just some abstract variables. This is predictor, this is response, and then you can see that, for example, x is mean-centered in this case, right? This is the equation of line for the population. This is the equation of line for the sample. And then, if, for example, you can see that the slope of the sample is smaller than the slope of the population. And indeed, we can clearly see that from this line. So the slope of this line is smaller than the slope of this line, right? What you see here, it's the regression coefficients, is the bar plot representing the regression coefficient. So this is the intercept, and this is the slope for the population. So the gray bars are for the population, and you can see the points are for current sample. Okay. Now, what if I start taking a new sample, and then another new sample, and then another new sample? You can see that every time I take a new sample, the orientation of this line is slightly different, right? And then you can also see that the points, the coefficients, the slope and the intercept, they vary quite a lot, right? And then if I do it many, many times, you can see a very interesting thing that sometimes it's above, sometimes it's below the true population slope in this case and the intercept in this case, but it doesn't go that too much, right? So it's always around, it's always somewhere around. Okay. If I change the sample size to 5, for example, so the sample size is smaller, apparently the uncertainty will be larger, and then you can clearly see it again. So sometimes you have some extreme cases, but most of the time, again, points, the sample coefficients, they are around the true one. Although you can see, for example, this line is quite different from the population, right? So this is exactly the sampling error, right? So all these lines, the uncertainty in the orientation of these lines is sampling error. And indeed, you can see that the smallest sampling error is here in the middle, and the largest sampling error is on the sides, right? So that's why we see this a little bit strange shape in the previous app when I described the sampling error. Now, what happens if your sample size is large, for example, 100, right? So in this case, you have enough samples to represent the population quite well, and therefore the uncertainty will be very small. You can see indeed the uncertainty is very small. Okay. So you can think about sampling error is that the variation of the sampling regression coefficients are around the true one. Okay. Now let me introduce a very important thing. It's called overfitting. Because we have a linear trend here, apparently the best model that can fit this trend is the line. But actually, I can make a quadratic model. So you can see now we have a curvature. I can even make a cubic model. So you can see now I have a cubic model. I have a polynomial of degree 3. So this is intercept, linear term, quadratic term, and cubic term. Although you can see for the population, these are almost zeros, right? So you always have a kind of curvature, but this is 0 and this is almost 0. And you have a quite big coefficients here. But if you look at the sample, you can see that they are much larger or smaller because it's negative, right, than 0. Moreover, if I start taking a new sample, so look at this one, how different is it, right? So again, this is the polynomial of degree 3 for the population, although it looks like a line because this coefficient and this coefficient is 0, but you can see a small curvature here. And now you can see how big the difference is between the population and the sample. And then you can see how much larger this coefficient is compared to this one, and this coefficient is compared to this one, right? Again, if I take a lot of samples, you can see that all these coefficients, they vary around 0. They vary around 0. But sometimes they can be very heavy. And because you never know population, you have only sample, you have this dilemma of overfitting. So you can easily find a model that fits your data very well, the current sample very well, but it's overfitted, right? This overfitting, it's a problem of a small sample size. Moreover, it's a problem of the ratio between number of coefficients and the number of observations you have in the sample. So in this case, we have 1, 2, 3, 4 coefficients and sample size of 10. You can imagine what happens if you have sample size of 5, right? So you can see that the variation is huge. So that's exactly the dilemma or problem of overfitting, right? However, if your sample size is large enough, look at this. If your sample size is large enough, the overfitting is not a problem anymore, because in this case, you can see although you also have non-zero coefficients here, they are very small, and you will never, almost never, get a model that can lead to some unstable predictions, right? So overfitting is a problem when you have a small sample size but large number of regression coefficients. Okay. So how to tackle the overfitting? You need to use validation, and that's a topic for another app.